I am going to do a new test for you now, one that I mentioned earlier, the DLDM slowdown mode. I am going to use a very simple algorithm. I will name it DLDM slowdown. Use the DLDM with the DLDM template. We do not need a meter. And I will use the XP camera. I will run the DLDM for 5 iterations at 90 RPM with 3 cycles per iteration. Save the algorithm. I am looking at the DLDM to make sure I have turned off the slow down mode to show you what happens if you do not use this mode. Back to the algorithm. Execute. I will use the label No Slow. Execute. I am waiting for the XP cam. Notice that when it stops, there is a big sag. That is because the motor overshot. It coasted partway into the next cycle. Now we will modify the algorithm for the slowdown. We will run 3 iterations. Set the DLDM to turn on slowdown mode. Execute. Label with slow. I am waiting for the XP cam. We can see it is in the slow cycle, running very slow. And when it stops, the sample is perfectly flat. Again, the sample is perfectly flat. And at the end, the machine stops when the sample is flat. Let's look at the snapshots. We started the slowdown test with the sample still sagging from the no slow test. You can see during the test that the snapshots show the sample when flat, and the measurements will be made when the sample is flat. If you look at the no slow, all the snapshots were sagging, and that's where the measurements would have been made. You will need to test your motor with jig to set your stop timeout. It can vary among motors and which jig is attached.